Okay, so this is going to be the second video that I make. This is going to be completing the MATLAB exercise from day one as a way to talk a little bit about some of the two things I didn't use in the video that I made yesterday. So I'm going to go ahead and start from scratch here. Here's MATLAB at the beginning, just opened up. First thing I'm going to do is create a new script. And I sometimes find it helpful to save right off the bat, just to make sure I know where things are going. I'll save this in my drive and 1215, which is the folder that you all will be able to see. I'm going to call it MATLAB 1215 MATLAB day 1 exercise. Okay. So this script should solve the parts from winter day 1. And I'm going to copy them below. And I may not comment too much as I go, because I'm trying to make the video of a reasonable length for you to be able to watch. So I'm going to copy these in. One quick trick here, I copied in my text. I can turn this into comments by clicking up here. I could uncomment here. It just makes it a little bit easier since when you copy in text. And you can also wrap comments will fix any wrapping over the line to make it a little easier. So the one thing that I didn't really want it to do was let's see if this fixes it. Okay, there we go. That's what I wanted. So first thing I'm going to do, I'm going to go look at this data. You won't be able to see the data because I have it on a split screen here. But first thing I'm going to do is create a matrix of the total engineering majors and major of the choice. So let's say total is going to be a 2x6 array of and you'll learn how to read in a file like this in 1216. For now, we're just going to input it in straight. 8, 3, 1, 6, 4.33, 4.21. Okay. And now I'll do, just because it's easiest, I'll do AE, which is aerospace engineering. I'll do the same thing. I'm going to say 61, 62, 74, 87. I'm sorry for kind of the dead time on the video here, but I just thought I'd show you live so that you can kind of see every step of the process. Okay, so that should create those matrices. Let's go ahead and see what it looks like if I run this section of my code. All right, so this is saying it's not consistent. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So this top one, I messed up. I forgot to put in the last number. And this bottom one, did I do the same thing? I put in maybe one too many. 61, 62, 74, 87, 88, 107. I put one too many there. All right, so that was just an error that I got telling me that I must have entered something in wrong because it didn't look like a matrix as expected. All right, so now these are both 2x6s. I can double click on the workspace if I want to look at something. And there they are. If I wanted to just get out, well, I'll just keep going. I was going to show indexing, but I think I do it in a little bit here. Compute and compare the average in your major of choice with the overall numbers. Okay, so now I need to average these together. So I'm going to actually switch this now to say total engineering. And let's say the average total engineering. This should just be the average function, and average AE is going to be average of AE. This seems like what I need to do. I'm actually about to make a mistake here, but let's go ahead and look at it anyway. Run section. Okay, so so average is not the function. And MATLAB's yelling at me because I've taught this class before, and in 1216 where we write functions, and I wrote a function average, which gives an error, a particular error message when I try to use it because I should be using mean. So, so mean is what I want here. So let's change that. So like I said, you're going to see issues live here, and that's my goal. All right, so there's mean. Now I think I'm still going to have another issue, but let's see. All right, so this is giving me a vector. I was kind of expecting just a particular set of numbers, like a total, but it's because I've got a matrix, and what this is actually doing is giving me column-wise averages. So it's averaging together 1032 and 4.38, and that is not what I want. That wouldn't make any sense to average at all. I want to average across my top row and across my bottom row. So the one way I can do that, if I want to compute I could go look in documentation is one way, and I could try to see how do I feed it column-wise. So mean, if mean is a row vector, okay. All right, here we go. Column vector containing a row of each, the mean of each row. So let's try that. Let's try to use this dim argument. So now I'm going to say, comma 2. Let's see what my answers are. See if they make sense. That's looking a lot better. Great. So that would say that for average of AE, 79.83. That looks pretty plausible for the average of these six numbers. I could even check it if I wanted to real quick. One other way I could do this so I could try mean of total engineering, and I could actually try subsetting this using the array indexing. If I just want the whole first column, but not the second column, then what if I said 1, comma, colon? That should give me the first whole column. Let's see if that worked. Take 2 test, 1.1605 e to the 3. And that gets me the same answer. Okay, so I could do either array indexing inside of my mean call to basically say, don't take the whole 2 by 6 matrix, just take the first row and average it together. Or I could use this dim argument, either one. Those are each ways to do it. This formatting is a little odd, and I kind of wish it wasn't doing that. I'm not immediately sure how to fix that, and by that I mean let's see. See if format long fixes it. If not, I will have to fix it on a different day. Yeah, that didn't do what I wanted. That just added a bunch more zeros. So I would like to kind of get rid of this notation. I'm sure that there's an easy way to do it. It may be in my preferences, but I'm not going to worry about it right this minute because I want to move on to the other parts of the solution. Okay, so output some text as a result of the number 2 comparison. So now I need to compare these two, which I hadn't done yet. So I want to say, I'll do one simple version. I'll say total years to degree. I'll do all eng years to degree, all AE years to degree. I'm going to use this array indexing total eng I want to do second row first, second row all numbers. Second row, all numbers. Okay. .4617, 4.315, and again, that looks pretty reasonable to me as I look at those numbers and kind of do the math in my head. So now I want to compare those two. So if I compare these two, I'll say all AE, years to degree. You can name your variables more simply if you want. I just like to be descriptive, even if it makes me type out a lot. So I want to say greater than all eng years to degree. Answer is yes, logical true. So that's saying that it takes longer in AE than average compared to all engineering on average. Okay, so I can store this as an answer if I want. I can say AE to all, AE greater than all, where my value would be a logical true if true, false if false, 1 if true, 0 if false. And then I can output some text as a result of that comparison. Okay, so I could say something like, here's how you can use fprintf. So I could say fprintf. Let me go ahead and suppress some of these outputs now that I no longer want to be looking at the answers to double check. Suppress all those outputs. Fprintf, I'm going to say, my prompt will be is AE, does AE take longer on average 2 degree than the rest of engineering? If yes, print 1. If no, print 0. And then I'm going to use this %1 f comma AE greater than all. Okay, so what fprintf did here was this %1f basically has MATLAB, when it sees this, it looks for replacing it with a particular variable that I now say over here. The %1 is what cues it in to be looking for it. F is referring to that this is going to be a floating point number as opposed to, say, S, a string. And I could actually use some different things here to print out different decimal values or different things. So let me show you what this looks like. So it printed an answer of 1. It's a little confusing here, so what I'm actually going to do now is I'm going to build in a line break to make it look a little bit better. So notice how my output down here changes. So now it dropped it on the bottom line. And I'm actually going to do now another one after this, then I'm cleaning up even more. All right, so this looks a little bit better. And notice I could change this. If I change this number to say 5, it's going to give me out 5 decimals, none of which matter. But this just specifies how many spots to save for decimals. So I'm going to take it all out because I don't care about the decimal. And this actually talks about how much space on the front end to save. So you'll notice that this looks different. It basically adjusts that over. The adjusting of this 5.5 or whatever I might be able to put over here, notice how it keeps changing. The adjustment there is all just about formatting if I want to format it in a nicer way. Like create a table if I'm going to repeat fprintfs over and over again. I want it to kind of look aligned or adjusted. Doesn't really matter for you right now. And again, you don't have to use fprintf, but I find this much easier. And you'll notice that actually this whole if yes print 1, if no print 0 thing is really unnecessary when you start to use fprintf. I just demonstrated here because you could essentially do 2 display calls, disp calls, one where you use this text and one where you just display this variable as 2 different lines of code, and you could accomplish essentially the same thing, but fprintf is a little more elegant and you're going to learn it down the road. So you could do it either way. So that's how you solve that part. I'm not, for the sake of time, I'm not going to input this because it's essentially just more data entry. Let's just go ahead and find the I'm going to go ahead and show you how to use max of a particular variable. So let's say I wanted to find the shortest time, the year of the shortest time to degree. So best year, all engineering. I want to use the min of, I want that particular row of my all engineering. So that is total eng, and it is the second row, all columns. See what that gets me. That pulled out the value of 4.21, which if I look at my data in 2013 to 2014, that is the lowest number. So min is a function which I could have looked up in documentation. And there you go. Now one cool thing about min is I can actually do this. Let's go ahead and show you what that looks like. This is if I set it equal to, instead of just calling min, if I set it equal to a vector, it actually gives me more information. It's going to give me the index, which is the element number. So let's say best eng, let me do it here. Best m comma I equals, let's say, best year value and best year index. This is going to equal, same thing here, min. So same expression, but now I'm just going to let it load in more information for me as it uses the min function. And I get 4.21 and in the 5th position. So if I were to actually go back and look at my data, I'll bring it over for a second. Here I am, 1, 2, 3, 4, 5th position, 5th year, here's my value. So that's kind of a clever thing you can do with min that you can find in documentation, and you might want to use that down the road. It's not the only way you could do it, but it is kind of an elegant way to do it. And also I didn't ask you, I asked you to extract out, but you could have done that other ways as well. All right, take a user input and compare it to the overall average and then print out. So user years equals input. Please tell me the number of years you want to graduate within. And then it's going to be a simple comparison. So using user years less than all eng years to degree. Say graduate in time equals user years. So this is going to tell me that if they enter in a small number and it's less than the number of years to degree, then they'll graduate in time on average. And now I will run this section, and it should then ask me for number of values within. Right. Sorry, I had a little bit of text left over that I've been typing in the command window. So please tell me the number of years you want to graduate within. So let's say 5. And now it's calculating behind the scenes because I suppressed echo. So graduate in time, 0, false. If I want it, so this is actually working backwards of what I wanted, so my logic must have been wrong. If I said 5 years, it's less than the years to degree, so that would actually be the opposite. I want to know if it's greater than. Let's try again. All right, 5 years. And it is now saying, yes, I'll graduate in time. If I want to graduate in 5 years and the number is less than that, average number is less than that, I will graduate before my kind of deadline. So if I wanted to print out the last thing there, I could print out something very similar to what I did before. This time I'll show this. Say, will I graduate before my anticipated timeline? And then I'll say 1 for yes, 0 for no, disp. I'm going to display just that variable, which is going to be user graduating time. Five, yes, I'll graduate in time. And if I wanted to clean up how this input worked, I could do like this, create a little buffer of space to make it read a little better. Now it looks a little bit better. There we go. So notice I use disp here instead of fprintf. Like I said, I like fprintf better. I think it's what you're going to use down the road. But if you would like to use disp, you can always use 2 lines of disp and get essentially the same thing. Okay, that will conclude this video. I'm sorry it's a bit long, but I wanted to solve through everything live for you.